Good day and welcome to Intermolecular Forces. So today we'll be going over the definitions of what makes a bond polar, covalent, or ionic, and then the different types of forces that they are and how to identify if the compounds are going to be a intermolecular force like an LDF, London dispersion, dipole-dipole, hydrogen bridging, and ion dipole. So to start off with the definition of what a bond is, there are three different types of bonds. An ionic bond, so the metal and non-metal ions. So if we go to the P table, now it wants a metal and a non-metal ion. So ion is a element that has a plus or negative charge. So if we take lithium, which is a alkali metal, it has a +2 charge or +1 charge because it has that one valence electron and it wants to create a full shell. So you're going to combine lithium with, say, something like fluorine. Because fluorine and lithium go well really together because lithium has that +1, while fluorine is a -1. So the fluorine is going to take the one valence electron from lithium, put it into fluorine, and it's going to create neon. Now for a polar covalent bond, you'd be PF3, and this is polar because we see that it has the lone pair, which is usually a good way to identify if a bond is polar or non-polar. This doesn't ring true all the time because, as we can see in the hydrogen fluorine, you can only tell it's polar because of the electronegativity difference. Now you could also look, to move on to non-polar covalent bond, NPC, it is going to have a equally shared amount of electrons between the elements. So if you take CO2 for example, carbon has a plus-minus charge of 4, so it's either going to give away 4 electrons or it's going to take 4 electrons. And that's being paired with 2 oxygens. Now this is non-polar because the carbon has a plus charge of 4 here, while the oxygen have a +2 charge, or -2 charge, and that is going to be unequal. Even though the two oxygens have a -2 charge, it's still not equal in terms of the fact that the carbon's losing all of its electrons. And then for the forces, moving on to the forces, a London dispersion force, LDF, is a part of the intermolecular forces. So you have the intermolecular forces, which is the main overall branch, which is the starting branch, and then you have the branches of the London dispersion, dipole-dipole, hydrogen bridging, and ion dipole. So London dispersion force, if we go back up here, is the weakest force of them all and usually has non-polar molecules. So for example, I think it'd be CO2 would be a London dispersion force. Yes, it is a London dispersion force because these two elements cannot combine normally, as in they can't just combine to make the full octet shell just by themselves. And this applies to mainly a good amount of metals that don't evenly share together. And then the dipole-dipole force would be an example of this could be the PF3. And this is the dipole-dipole because the phosphorus is donating the 3 electrons in it, even though it's a -3, but we're going to ignore that just for now because it's surrounded by 3 fluorines. Now the fluorine is going to take the 3 electrons away from phosphorus, which is going to give it a 3+ charge. And it's going to leave that lone pair, I'm going to make it polar, while everything else, the fluorine, are all going to achieve their octet. And since there's a 3+ charge on the phosphorus, if you add up the charges of the fluorine, which are all -1, is going to have a +3 charge and a -3 charge. That's going to create a dipole-dipole force. Basically, it's going to be the same number, but they're inverted. Now to move on to hydrogen bridging forces. This is mainly occurring with hydrogen and oxygen, fluorine, or nitrogen. Nitrogen, oxygen, fluorine. Doesn't work with chlorine, sulfur, phosphorus. Mainly because they have too high of a energy level that hydrogen can't really connect with that well. And as an example of this could be the hydrogen fluorine, for example. So that's going to be a hydrogen bridging force. And as we know that hydrogen and fluorine is going to be a linear in terms of the molecular geometry, because you have the hydrogen bonding to the fluorine, which has the 7 electrons on the perimeter, and hydrogen just has 1 valence electron, and it donates it right into the fluorine. That's why it's linear, and that's why it's a hydrogen bridging, bridge meaning the bond here, force. And then we have the ion dipole force. Now I think there was maybe, I think that's 5 actually. Yeah, it is 5. So an ion dipole force is whenever you have a full compound, so potassium and bromine, that creates the full octet of krypton, because bromine and potassium are on the same energy level, so they can combine very easy, and they make krypton. Then it says it's in water, or H2O. That means it's going to break down, and the only thing that breaks down is an ion dipole force, because ion meaning the combination of potassium and bromine, and then the dipole comes from the water. So that's practically it for the polar and how to identify if they're polar or not, and then the different types of bonds. I'll go into more in depth about how to solve this all right here tomorrow, but this is how we're just taking it step by step by step, because we have to learn the basics on how to solve this first, and then we can move on to this. And to see my work here, this is what you can put down for the first table right here. And you can pause here. Okay. And then a bit of my work up close if you cannot see from that. And then the next bit, you need a closer up. So basically you just have to write down the Lewis dot structures and how they are bonding together, and give an explanation of why they're bonding, why it's nonpolar, and then the force and then the force. Alright, and that concludes the video for today. Like I said before, tomorrow I'll go into depth on how to solve all this, because I haven't done it yet. So thank you for watching, and goodbye. I told you I'd make it by 5.